All right, so welcome to our first day of factoring simple trinomials. What we want to start off with is just remind ourselves a bit of binomial expansion. So you'll remember that we use an acronym FOIL in order to expand the two questions here that are under consider. So we would basically take this x and multiply it by that x and wind up with x squared. We take that x and multiply it with that 3 and get 3x. We take that positive 2, multiply it by the x and get 2x, and that positive 2 multiplied by the positive 3 and get a 6. You'll notice that almost always those two middle terms wind up being like terms and be collected, right? So the 3x and the 2x can be collected to give you a positive 5x. And the first term doesn't have any other terms that are like it, and neither does the last one. So that would be the answer to that one. Okay. The second example, I guess I'll change colors. If we were going to basically FOIL that, we'd get x times x, which is x squared, x times negative 3, which is negative 3x, and negative 2 times x, which is negative 2x, and negative 2 times negative 3, which is positive 6. And again, just like the last problem, those two middle terms are like, and we can actually combine them to wind up being x squared minus 5x plus 6. So you'll notice that in both of these situations, the second numbers, the 2 and the 3, and the 2 and the 3, they were the exact same. The only thing that changed between these two examples, example number 1 and example number 2, was the actual sign that was in between. Right? We had a minus 1 there and we had a plus 1 here. And you'll see that in the very final result, the numbers were the same, the 5 and the 6, but the sign was a little bit slightly different, plus and a minus. Okay? The real key concept right here is to remember that factoring is the opposite process of expanding. Always remember that concept as we go through today's lesson. So what I want to do is jump straight into some examples. Okay, so here we're asked to factor each of the following trinomials. So remember that factoring means to basically take this and to turn it into something multiplied by another thing. Well, that's going to be kind of difficult to do with these four examples here because, well, this is not something multiplied by something and there are no common factors. So I can't, common factor an x out because there aren't any x terms with this last constant, right? So we've got a bit of a dilemma here. Well, if we pause for a moment and think about this, this is a trinomial, right? There are three terms here. And if we think about it, this was actually probably the result of a FOIL problem. So we know what the original FOIL kind of looked like. It was a set of brackets. And we know that that first term was probably an x, because x times x is x squared. But now we got to ask ourselves, what are these numbers that would go here and here? Well, let's do a bit of prediction. Let's predict some of the signs. Well, that sign at the end, it's a positive, it's a plus 12. That means that whatever this number was times whatever this number was a positive. That doesn't really tell us much, right? Because this could be a minus and this could be a minus, or this could be a plus and this could be a plus. One way or another, both of those signs have to be the same though. So I'll write that down. Same signs, no matter what. Don't know whether it's a plus, don't know whether it's a minus. This little guy here though gives us a little bit of a better hint, right? That's a plus 7. So both of those numbers, both of those terms that would have added or collected together to be 7x, they added together. Now, if they had the same signs and they added together to be a positive, they must both be positive. Now all I have to do is try and figure out the numbers. So you'll see this quite a bit as we go through, through dealing with trinomials. It's this. We're going to write down adds 2, and we're going to write down m for multiplies 2. Sometimes teachers will write P for product and S for sum. I like to just write adds 2 and multiplies 2. So A and M. So it must add 2. We're going to try and think of the two numbers that would add to 7 and that would multiply to 12. Now you're going to sit there and rack your brains for a little while if you're not very good at multiplication, or if you're really good at multiplication, you've already figured out the numbers that I'm about to give you here. Okay? So you're looking for these two numbers that would add to 7 and multiply to 12. Pause the video right now and think about it if you need to. All right, so hopefully you have discovered that those two numbers are 4 and 3. We'd be able to check this answer and any of these answers by using FOIL. So if you wanted to, you could check this by saying, well, what's x times x? It's x squared. What's x times positive 3? It's positive 3x. What's 4 times x? It's positive 4x. And what's 4 times 3? Positive 12. And then realizing that this term and this term collect to make the 7x that you had in your original question. Okay, so again, all that I've written in red is just checking my answer. It is not part of the answer at all. It is not part of factoring. That's the exact opposite of factoring. It's expanding. Okay, so what I want you to do is to consider B, C, and D. I want you to think about what two numbers would add to and multiply to, right? So for question B, adds to and multiplies to. So the number that it has to add to would be this middle term because it was created through collecting like terms. So it has to add to -8. The two numbers that we're looking for in terms of multiply to would be 12. So again, what we're thinking about are these two numbers. We know that the result has to wind up being like a FOIL problem. In this situation, the first term would have to be an A, and the two signs. Well, the two signs, because their product was positive, have to be the same. The signs are the same again, but we don't necessarily know what they are just by looking at that plus 12. We have to look right here. That little sign there tells us that because they're the same sign and they added together to be a -8, both of the signs have to be minuses. Okay, so now we don't really have to worry about this minus that's here, the -8, because we've taken care of that. But what two numbers would add to -8 and multiply to 12? They would be negative and negative. Okay, so I want you to consider examples B, C, and D. So what I want you to do in just a moment, after you pause the video, is to consider what adds to and what multiplies to for B, for C, for D, and I want you to fully factor them. Okay? Okay, so magically your answers have appeared. For the answer for B, the two numbers were 6 and 2. Don't forget, again, that they had to be negative because of that sign thing that we were doing earlier. The same analysis happens for question C because we had a positive product and a negative sum. Sorry, I think I erased it accidentally here. Our positive product of 8, they had to basically be both the same sign, but they had to be negative. Now, I know what you're probably wondering. Would it have been acceptable to write instead C minus 4 and then C minus 2? Of course it would have been. That's also correct because order doesn't matter when we're just dealing with multiplication. Okay, so that's fine. With question D again, D is really similar to the very first in that both signs had to be the same. They had to be addition because both of those were positive. They added together to be a positive number and they multiplied together to be a positive number. Okay, here's 6 examples. Okay, so I want you to pause the video, give these 6 examples a try from start to finish, and then unpause your video and come on back to us. Okay, so the first 4 solutions are posted here, and I wanted to walk us through a bit more of the solutions. So you can see that clearly with question E, I had an adds to 9 and multiplies to 20. My two numbers were 5 and 4, but there's a bit of a problem with this question. Okay, the problem is here. We've got y's bouncing around as well as x's. So if we think about our first term, x times x, yes, that would satisfy that. But our last term, 4 multiplied by 5, would not give us 20y squared, right? Because there aren't any y's in our answer. Well, why don't we just put them there? And that's actually really where this comes from. We just put them there, right? So we just put the y's there. If you think about it, 4y multiplied by the 5y would get you the 20y squared. And that middle term would be x times 5y, which is 5yx, and 4y times x, which would be 4xy as well, right? So your middle term would wind up having xy as its variable. So you're still safe there, okay? So the y just gets popped onto the back. And that's actually the same thing that happens for f, g, and h here. The q gets popped onto the back of both of these. The b gets popped onto the back of both of those. And the d gets popped onto the back of both of those. Notice the question G is a little bit tough because our two numbers are -1 and -2. Those are often forgotten ones when we're factoring trinomials, right? Because we don't even really have to write the -1b here. We could just write -b. And that would still expand to be the correct answer. Right? Our last term would be -2b multiplied by -b. Negative times a negative is a +2b squared. Okay, so just so that you're aware. Finally, with questions I and J, that's where it really starts to get a bit interesting. With questions I and J, you'll notice that there's a number in front. Like I circled it and put a question mark. Like, what do we do with that, right? Because that first term couldn't be x times x, because x times x is just x squared. Where's the 2 going to get dealt with? Well, here it is, folks. You'll remember the previous lesson about common factoring. If we can common factor a 2 out of all of that, we should really do that first. And yes, we can, right? That's an even number, that's an even number, and that's an even number. So what we do is our first step is to common factor the 2 out of that trinomial expression. This is a great idea for a few reasons. Reason number 1, it makes the numbers that we're trying to add to and multiply to a heck of a lot smaller. Reason number 2, again, the first term is really not all that clear, right? The 2 has to be kind of factored out to begin with. So then what we're going to do is basically factor all of this that I'm underlining in green the same way we've been doing this entire lesson. So we're looking for things that add to 7 and multiply to 10. Those two numbers, 5 and 2, I think we've already seen those before even. So there's the 5 and there's the 2. Again, don't forget you could have written x plus 2 in brackets and then x plus 5 in brackets. That wouldn't have really changed much. J is absolutely no different. Again, we've got a negative 3x, and that is factorable. So what we're going to do again is factor that first coefficient, that lead coefficient, out. Okay, so that negative 3 is going to get factored out, leaving us with x squared minus 9x, because it was positive, we factored out a negative 3, plus 14. Then what we're going to have to do is take a look at what's inside, factor that trinomial, just like we've always been doing. So we're going to look for numbers that add to negative 9 and multiply to 14. Okay, so that negative 3 still gets written on the outside. It's still there. It hasn't disappeared, right? The stuff on the inside, we know it starts with an x. We know that both of the signs are going to be minuses. They're both the same signs. And the two numbers are 7 and 2. Okay, so you should know that you'd be able to expand all of those in check by FOIL. Okay, so hope you've enjoyed the video. Again, if you need to, rewind. I know it went by pretty quickly, so rewind the video, watch it again, watch it several times, and make sure you get the concept. Have a good night.